In this lesson, we'll be talking about polynomials. Well, polynomials with given values of x. If you notice here, I didn't write P1, P2 as the other polynomials because we just have one polynomial question given. If you notice here, I didn't label it P1, P2 because we are giving just a question, just one polynomial. In the case where we have more than one polynomial given, that's why we label it P1 of x, P2 of x, like that. So now here we are going to substitute like we did in simultaneous equation of substituting. So the values that were given to us in the first one is x, we'll replace it with 1. X here, we'll replace it with -2. X here, we'll replace it with half. And then x here, we'll replace it with 0. And see what value each of them will give us. So let's try to solve them. The first one is P1 is equal to, now instead of putting x, now we'll change it to 1. 1 raised to the power of 3 plus 4, 1 raised to the power of 2 minus 3, 1 plus 1. The constants remain the same. There's no variable given to it. So 1 raised to the power of 3 is 1, plus 4 times 1 is 4, minus 3 times 1 is 3, plus 1. Let's add the positive numbers first. 1 plus 4, 5, plus 1, 6. So we have 6 minus 3. The answer gives us 3. The next one, P of -2. Now anywhere we see our x, we put -2. So we have -2 raised to the power of 3 plus 4 minus 2 raised to the power of 2 minus 3 minus 2 plus 1. -3 raised to the power of 3 is -8. Plus, before we do that, plus -2 square is 4. 4 times 4 is 16. Minus times minus is plus. Plus 2 times 3 is 6. Then plus 1. Let's add all the positive numbers. 16 plus 6, 22 plus 1, that's 23. 23 minus 8 gives us 15. Okay, let's do the last. Okay, no, not the last. P 1/2. So anyway, we see the s, 1/2 square, 1/2 cube plus 4 1/2 square minus 3 1/2 plus 1. So what we have here is now 1/8, because 1 raised to the power of 3 is 1. 2 raised to the power of 3 is 8, plus 4, 1 raised to the power of 2 is 1. 2 raised to the power of 2 is 4, so we have 1/4 minus 3/2, that's this 3 multiply 1 on top, plus 1. 4 here 1, 4 here 1. So what we are left with is 1/8 plus 1 minus 3/2 plus 1. So what we have here now is 1/8. 1 plus 1 gives us 2. Plus 2 minus 3/2. So now let's make everything fraction so that we'll be able to solve the fraction. The LCM of 8, 1, and 2 is 8. 8 divided by 8 is 1. 1 times 1 is 1. Plus 1 divided by 8 is 8. 8 times 2 is 16. 8 divided by 2 is 4. 4 times 3 is 12. Minus 12. So 1 plus 16 is 17. 17 minus 12/8. So what we have here is 5/8. That gives us the value. Then the last one is P of 0. So anywhere we see our x, we put 0. So we have 0 to the power of 3 plus 4, 0 to the power of 2 minus 3, 0 to the no power plus 1. So we have 0 plus 0 square is still 0. 0 times 4 is 0. Minus 3 times 0 is 0 plus 1. So 0 plus 0 minus 0 is 0 plus 1. The answer is equal to 1. Now, we can still use the same way to solve this polynomial too. So given that P of x is ax squared plus bx plus 1. If we recall, we can still remember our quadratic. It comes in this form. So this one is giving us question as quadratic. And they say P1 is equal to 6 and P minus 1 is equal to 2. So now they say we should determine the values of here. They say determine the values of A and B. We are to determine the values of A and B. Here they are giving us question that looks like a quadratic equation. So just the way we solve this, we'll apply the same thing here. The P1 we will now call ax squared plus bx plus 1. Now wherever we see x, we put 1 because that's what the question say. Okay, so we put 1. This is P of x. P of x is equal to this. So we have x is 1 squared plus b is 1 plus 1 is equal to P of 1 is what? 6. So we have 1 square is 1. 1 times a is a. Plus b is b. Then x is 1. Plus b times 1 is equal to b. Plus 1 is equal to 6. So we have a plus b is equal to 6 minus 1. A plus b equals 5. This is equation 1. You can still remember our simultaneous equation. I will solve them. Okay, continuing what we did, well, exactly what we did for the first one, we'll do for P of minus 1 equal to 2. So P of minus 1, we still have our ax squared plus bx plus 1 is equal to P of x. P of minus 1 is a minus 1 squared plus b minus 1 plus 1 is equal to, the value there is 2. So we have a minus 1 square is 1. 1 times a is a. Minus b times minus 1 is minus b. Plus 1 is equal to 2. So we have a minus b is equal to 2 minus 1. So a minus b is equal to 1. This is equation 2. Now we use the elimination method to solve. We have a plus b is equal to 5. A minus b is equal to 1. If you look at you want to eliminate a and a, none of them have any coefficient greater than 1, so there's no need multiplying everything everything by the coefficient of a. We just subtract directly. So we have a minus a 0, b, that's 1 minus this minus b, minus 1 again, sorry. So we have 1 plus 1, which is equal to 2. So this becomes 2b is equal to 5 minus 1 is 4. Divide both sides by 2. So what we have, b will now be equal to 2. Now where b is 2, substitute b equal to 2 in equation. Let's pick equation 1. Equation 1 is a plus b is equal to 5. and our b already is what? 2. So we have a plus 2 is equal to 5. So we have a is equal to 5 minus 2. A is equal to 3. Now, wherever we are given polynomial as this, we can as well solve it this way.